Yes. Bienvenidos a Buenos Aires. Gracias para escuchar a mi presentación sobre Arkiv, una solución de Web3 por los datos. Y porque mi español es no bastante, necesito cambiar en inglés.
Okay.
Okay. Thank you so much. I'm very happy to show you Archive. It's written Arkiv, but most people say Archive, so we also say Archive. My name is Matthias, and I'm the tech lead of Arkiv. I joined Golem helping to build Arkive 3 months ago. I'm one of the leads person to do the Python SDK, also the JavaScript SDK to how to interact with Arkive. So we really would want to be able to integrate and talk to builders and I'm sorry, Martin, less marketing and more build stuff. And I hope that works for you. So you're talking about the elephant in the room, and it's basically the elephant regarding data in Web3 space, because from Web 2 we are used that we have data in an easy, fast, convenient, and cheap way. However, the problem is that whenever you use a database on Amazon, on Azure, on AWS, Google, it's always centralized. So if our dear leader Trump decides that you're a bad country, your data is not available tomorrow, and this is not really a sustainable solution. And there's a reason why there is a blockchain. So people want to have permissionless data. They want to have reasons to believe that whatever they do on the internet is still there tomorrow, and not just because some random stuff happens, it's gone or blocked. So somehow, if you're in Web3 space, we do not like the fact that something is centralized and can be just turned off by the link of a single person or a single entity. So in Web3, what the really nice properties we have, it's trustless, permissionless, it's decentralized, it's verifiable, but it's always quite expensive. And especially data is super expensive. So if you want to put 1 megabyte on Ethereum, even if it's a layer 2, it's still very expensive. And one of the really, really big pain points is if you want to query a lot of data, and this ends up in many RPC calls to your node, your UX or your application to the user is getting really, really slow because of the many queries. You cannot use the nice features that you have in a database. So basically, currently situations, you have to pick. Either you have the convenience and the low price, and then you go centralized, or you go the more decentralized way, and you lose convenience and you lose the price aspect. But we think this is a question that really matters, and especially in areas like AI, DeFi, gaming, or Internet of Things, or physical networks, infrastructure, all they need basically live and queryable data. So in principle, you can push all that data to a blockchain, but as soon as you go to query or want to have live stream, it's really getting hard. And more often than not, applications that want to build decentralized solutions are forced to at least cache their data on centralized pieces to serve the UI or something like that. And yeah, so in that case, your application, even though the data might be in a smart contract, your application is still basically free to decentralized API that might not be there tomorrow. And Web3 builders are stuck in indexer hell, basically treating this with good indexes and trying to come up with clever ways to work around that, or they go for centralized ED and inherit all that bad stuff. And the current Web3 data pooling lacks developer experience and also lacks user experience. This is the principle while people go on Amazon or decide for Web2. So to summarize, currently you either decide for Web3 and you accept that you pay large amounts of money for transaction costs to push out of data to on-chain, or you give up on good developer experience or user experience. If you want to have this good user experience and developer experience, you're kind of forced to accept that there is some centralized things in your tech stack that serve your application. And in which case, you start to lose on the promise of blockchain technology. So the question we from Golem had is, we actually want to have both sides. Why can't we have both sides? And Golem comes from, is basically a protocol on Ethereum that does decentralized compute and also has a marketplace to match the people that provide compute and the people that use compute. And this marketplace data is pretty complex, needs to be queryable, and has basically all the properties that usually kind of forces you to almost go a centralized way. And what we had before, we were not really satisfied, so we really pushed for trying to get, can't we just take something that helps us to solve this problem? And we actually would have loved to take something that's also a problem. However, we just didn't find anything. So even though we did not want, we felt kind of forced to come up with our own thing, which is basically a Web3 database. And while we were building this Web3 database, we came to the conclusion, wait, maybe we are not the only ones that can take advantage of these properties. So while building the thing during this year, our confidence in building something cool reached a point where we thought, why not fork this away and make it available as its own protocol and then move our stuff on top of it. But then all the other builds can also move on top if they like. So what we want is the thing is queryable by design, deterministic. So if you shoot the same query at the thing, then you can expect the same answers. The time scope, this is something for marketplaces in many applications. You don't need the data to live forever. If you do bookings of a hotel, once you have consumed your stay in that place, if you go for a concert ticket, once the concert ticket is over, the data does not necessarily still need to be there. If you do a standard Web3 approach on blockchain, once you store the data, you pay the money, it doesn't matter if it stays forever. You stay the same amount, it's basically eternal. Many use cases do not require that data to be eternal. And then we can take advantage of the property that the data has a natural expiry on basically from its business case. We can also use that for housekeeping, which basically means that the amount of data that needs to be stored at any given moment of time is kind of much more manageable if you have those two things. I'll come to that a little bit later. Then, of course, permissionless, everybody should be able to push data, everybody should be able to read data. The thing is, then of course, once you push your own data, that data belongs to you. If you push a piece of data, which we call an entity, nobody else is supposed to be able to change that entity, only you its own. So this is where, if you own something, then you can actually control it. You can move that to somebody else, and then the other person can control that for the data if you want. So let's look a little bit under the hood how this is built. We have these three layers. Layer one is the anchoring layer. In this case, it will be the Ethereum mainnet. The layer two is just a standard optimism layer like Base or something like that. It's built using vanilla optimism stack directly from the sources, not modifying anything. And then on top, we have the so-called DB chains. So all layer two, which is called Arkiv network, is just used for coordinating the different DB chains. We have one that we provide. Eventually, we want a system that everyone that wants to spin up their own DB chain, they can do so. Or if you want to add more nodes on the DB chain, you can decide on which one you want to run. Then here, the layer 3 is also built on top of Optimism, basically using the Optimism stack, but not vanilla, but modified. So if you have this peer-to-peer network of Optimism, like we're using the GET client, we attach to each client, we attach a database, a CQ-like database. So when you store data on that level, you send a classical transaction, it's just the data part, and then the node knows which is the data and which are the attributes and how to organize them in the database. Once they're on the database on every node, independent on to which node you're talking, you have the power of a classical DB to do queries. So not one RPC call and the next, and then the next. You give all your conditions like a composable with and, with ors and nots and range criteria, and you get back dozens or hundreds of entities, just like in a paged query set, as you would use from a classical database. So much for the architecture. Also is economics that make the whole thing feasible, because cost-based, the scale is how much data you store and how long they live. That's the point that I mentioned before. The more data you store, the more you pay. The longer you store the data, the longer you pay. Whereas if you go on any classical blockchain, if you store data, you can pay once and that data is there forever, but you also pay forever. So what we want is that to store data is much, much cheaper than currently on mainnet or any layer 2 that is around. Like factors of maybe 100 times cheaper than current layer 2. It will be more expensive than Amazon because it's very hard to compete on that kind. But eventually, we'd like to move closer to Amazon than on the price range, closer to Amazon, while still keeping the Web3 promises and properties, and instead of going the standard blockchain pricing layer. Even though they get less expensive, we would strive to be substantially less expensive for them. And already said, and yeah, how do you pay? Because the whole thing is financed by Golem. Of course, it will ask you to pay this Golem. Not on testnet, we have process for that, but the cost will be really low. Initially, you will need to pay this Golem tokens. Over the time, they'll add support from multiple tokens. So you can also pay with other tokens on other goods. They will be in exchange for Golem, and that will be basically by how you manage your data on these DB chains. So Golem tokens evolves from being the token for decentralized compute. This was I was initially mentioning where Golem comes from, to also support data on Ethereum aligned, and yeah, of course, because we're in Ethereum shop, we love Ethereum, so we don't need to build on stuff. It's effectively locked, so no reason to change anything. It's not only built on top of Ethereum technology, but we think it's also built for Ethereum, just to complement like your classical blockchain. If your data is getting too complex or too costly in your smart contracts, we think it's very viable to consider to move the data on top of Arkiv and keep links. Like if you have an entity, the element to store data is called entity. If you have an entity key, you can basically just save only the entity key in the on-chain thing and the block number, because you always need to have to because entities data can change. You need to specify at what time, basically the block number of that entity. If you specify the query, the block number, you're guaranteed to get the same answer. Because otherwise, over time, the owner of the entity can also change the data. But if you give the block number, then that data stays valid forever. Then, yeah, so it's basically a future-proof data layer that adds this value to Ethereum, scalable, verifiable, and anchored on layer 1 security. And also we want to add a burn mechanism. So be a good citizen in the ecosystem of Ethereum. So through the fees that we collect, and also burn part of these fees directly on Ethereum. So what makes Arkiv possible? Basically the use cases. The first one to name is the one that we actually will use it for. Decentralized marketplace for compute, basically the people that provide compute and the people that request compute, but it does not need to be a compute. It can be anything that is marketplace. The offers and the requests can all be put on Arkiv. You can query easily to find what would match, what request would match which offer, and then you can go from there. Once you have identified the match, you can create match entities, and in the smart contract, for example, you just point it to the match, which gives you the audit trail to why the match has happened in the first place, and then total movement, like real value movement, you could do with smart contract and classical assume or later features. Then, of course, like NFTs, real-world assets, and smart contract metadata. NFTs in the sense that often NFT metadata is also hosted on centralized services. It would be good to consider to actually move the metadata or small images. This would be a very nice candidate to move on Arkiv, or anything that has basically kind of complex data aspects that are getting slightly too complicated for smart contract approaches. This is a consideration. Then decentralized physical infrastructure networks, IoT feeds. Like, let's say you have an IoT device that measures kind of somewhere, gives something like a measurement every 10 seconds or every minute. Then it could have an account on its own and push its own data on an Arkiv, which then leaves a trail of auditable data, which can then again be referenced or used in some other scenarios versus just storing that data again on a centralized database. And open analytics, we mentioned this because we think that the query feature is really cool, and then of course whatever data services you have for record design. So we think data autonomy is inevitable. So we want to move as many people away from centralized data stores to something more DeFi aligned. And we think that the next billion users, we must not leave them only the choice of the classical Web3 that is kind of clumsy to query and super expensive, or then have the centralized approach. So we want to offer them an additional option that basically combines the best parts of the two worlds. Yes, now get started. We have tried to create the hello world for Arkiv that lets you get started without any installation. It's purely browser-based in less than 5 minutes. And we think that is a good way to start. Also for the hackathon, you have some more material to follow on how to do your local installs and connect to the testnet, of course. And how are we in the timing? So I don't want to stress your time budget, but maybe how much more time do we have?
The time?
Yeah.
10 minutes.
10 minutes. Okay.
Yeah.
So let me try to do that. So if you want to learn more about Arkiv, then this is the archives.network, is our homepage. Then kind of blurry. Was it always blurry? Okay, I'll just say. So here you would go to build now, and then there's this quick start button, and here's the Arkiv hello world. So if you have, this is just an address and a private key. So if you click multiple types or regenerate account, you can go to different accounts, addresses and private keys, and then you can open the faucet. And ideally, it should copy the account address to the faucet. Let's see if that actually works. TF2A. Okay, yeah. So this is the Arkiv faucet. with the address that you just created before, and then you have to do this capture thing and maybe move around your mouse cursor. Unfortunately, this is not. I just figured out by talking to someone this is not working on a mobile phone. It's nice that it can also work on a mobile phone. I think for now you have to use just a normal web browser. Request test tokens, then that's basically the faucet transaction. And now it tells you how many more blocks you have to wait. So there's a little bit of a wait time involved until your account is actually funded. And so now we're still waiting for 16 L2 blocks to be processed. And this like 60 seconds is the approximate wait time you have for that account.
The faucet is good.
The faucet is good. So the only thing you need to do is to click here and move your mouse. You don't have anything else that prevents you from acquiring these tokens. You think it's too easy?
Everything explains the burning token and survival. The burning token is briefly explained. The burning token increased your value. ¿Cómo que más interpretan para que aumente su valor?
The current value of the token, this test token 0.
Zero.
Yeah. Ahora. I mean, later it's just the golem token value of the thing, but you will see when you play around that with this very little golem you can do a lot of it.
Okay.
But to learn and to use and for the hackathon there are 0 costs in just like this thing. Okay, still waiting for one more block to be processed. So basically we should be able now to go here and we have then this Hello World application. This is using the TypeScript SDK. TypeScript SDK is basically built on top of VM. So when you're used to one of these libraries, you don't need to learn anything new, but it just comes with additional functionality that uses that entities to store and retrieve data. If you want to query how much funds you have, if you want to see on which network here, or if you want to check the block data, then that's standard out of the box as you use from the underlying library, so nothing. And then here, this is a live editor, so I can click here on play, and hopefully I will see then here the thing executing. So we have the execution completed. Here it's basically maybe look a little bit at the code. The code here we have we create the client first. That is show the RPC endpoint of our network. And then we have an account that is linked. This account is basically linked to the private key here. That was the one that we just funded before with the faucet. And once we have the client, we can use this to say create public client. Oh no, the client, and we use this here, wallet client create entity. So this is where we actually do the data. So everything interesting for the entity, for the data that we store is in this bracket. We have here field called payload, which is just a binary you can store, unstructured binary, whatever. It can be a picture, it can be a JSON, and that you can provide here. Then you say you can provide the content type, which usually should be a MIME type, like text plain or application JSON, that basically describes what in what format you have put in the payload. So it's easier for other people to read the bytes there. And this are the attributes. So in this case, we have 2 attributes. The type attribute is set to the word hello, and we have expires in, which basically expires in 120 seconds. But we can also put like 2 months or 3 months of seconds over there. And once we have created that entity, we can open the block explorer. And if I was not talking too long, we actually see the entity here. So we have, these are the details from the transaction. And there's a link which is for data and annotations. So you see the string that we say here is hello archive. And this is the type hello. And this is the operation. So basically, a create operation. What we can do is we can go back and let's modify this a bit. Buenos Aires, and we then execute this just to see, to show that this is a live editor, so you can play around with a 0 install. And on this side, again, we should basically get a new entity here, just making sure that yes, this one, or I can also just copy this one and switch back to this Explorer and put this into search field and say, now I want to see this entity. And if I go to data annotation, yeah, we have the all of Buenos Aires data. So, okay. That's about the demo. If you go back on this page, there's more details here and more information here, but we try to make the initial start as big as possible. And we, of course, also will be here to help and answer questions. We have a Discord, so it's also, please join our Discord. It's also a very good place to ask questions, and we try to be responsive on your questions.
I have one just curious. How do you manage the storage size of the file?
Well, the storage of one file, basically one entity, whatever you put into this entity, or you can also have calls that store many entities at the same time, you send that as a transaction to the layer 3 node, which means that you have the restrictions of the transaction. So the transaction size is the maximum size, which is currently around 120K, so 100K. So basically, this is, in a single entity, you cannot store more than this 100K data. If you want to save more data, then you have two options. One is to maybe better. Let's say you have a gig or a terabyte file. Then one option would be to save that file on IPFS, take the hash, and add the hash in an entity with all the metadata you need for query. Or if it's not that large, you can split the larger file in small chunks and come up with a chunking way of do one file in over several entities that maybe share the same UUID to basically stitch together the pieces at the end if you then your application would need to split and stitch together. Yes.
Like a couple of years ago, I bought some, Chia coin, like the Chia coin. So I got, all the hard drives, put it together and put it to mine. That sometime later, that went to zero and was like abandoned.
Yeah.
So what's the difference here with the kind of, what is like the main value, the query part, the how you mine or how you put your storage to use, how that storage part works, or is like what are the nodes or the miners?
So currently this test method is operated by us. But the idea, of course, is that if you want to operate your own DB chain, you can do that. And then what we have not yet finalized is we would want to have a setup where nodes can be added to a network and they participate in the value created on the network. So like they get a share of them, whatever tokenomics. We are not yet that far. And I mentioned that we started early this year, so you're really among the first people that get a live introduction in what we are building. And so yeah, but definitely we need to consider how we scale, how we make it attractive for people that want to support the network by providing hardware. We have some experience from decentralized compute. We also need and we consider collaborating with a distributed compute server that wants to become more decentralized and see how we can collaborate with those guys. And for example, they're renting out massive amounts of GPUs and they claim at the lowest price where you can get GPUs.
Yeah, like Big Tensor, because I'm also into that part of the, I think Big Tensor, you can put your GPU like 1, 3, 6.
Yeah, the service of these guys is called Salad.io. So they're based in California or in the States, and we just started. It's really early time. We just started to chat with those guys, and we'll see how it goes. So basically, it's the same. They also have this marketplace, and currently the whole marketplace is centralized and behind, so it's not transparent for the people. But it's just they're told there is an offer and this is the price. It's hard for the user to be compared, or hard for the providers to see who gets how much and what. Does that kind of answer your question?
Yeah.
Any other questions?
Just to say also from the demo you were showing, is this QR code in the leaflet is a special website from Arkiv only for this week. It has all of the team, all of the events that we will go to, as well as direct link into code everything. So if you click on this one, you can access all the extra information.
So is this the hackathon dev portal link? Or
Yes.
There will also be this, if you click on this dev portal hackathon and you move down, you'll see this
Exactly, yes.
somewhere,
It's Hackathon.
Huh?
The website is not current.
I thought we had a place where we could
It's
where we could
slash
see all
Argentina like this.
Argentina 2025.
Hey, that's right. That's right.
We're very creative. you see.
Yeah,
Argentina
yeah.
25, okay.
Yeah, so this is the East Argentina Hackathon thing, and this is the price stuff that we do for the hackathon. The main price is 2,000 US if this thing says, and second place would be 1,000, and there's like side price for a little bit less. Great. Yeah, but I mean, would be more the marketing guy to hey, thank you for coming. Organizational questions regarding hackathon. We can maybe address more through Martin and technical questions to how to work with the SDK and maybe just chat about potential use cases. Yeah. You stick around. You can also say stick around maybe 1 more hour or something like that. And we have stickers if you want also. Great. Thank you so much. These are the stickers, the different ones.
Oh,
One final point, kind of unrelated, not exactly about Archive, but as Matthias said, we are part of party drinking.